Okay. So a scrubber is used. So basically, what scrubber is? Okay, we need to know what scrubber is. So scrubber is nothing but a kind of a device which is used to, I mean, reduce the temperature of water and or collect dust particles. Okay, for when there is no back filter. So when the dust particles are very fine, okay, so during that time it is not possible always to collect using back filter, so there's a scrubber. So what scrubber does is it sprinkles some water, okay, like this. So it sprinkles water and all the dust and whatever the temperature is, it is reduced of the gas, okay, so that we can uh, meet the process requirements, okay, process or emission requirements. So now here we have a problem so where we need to find out how much water we need to continuously add to wet scrubber from outside, okay, which is called as makeup water, so that the unit keeps running and it keeps on removing the dust particles, okay. So let's see what is given. So each number of streams is identified by a number. Okay. Stream 1 is the recirculation liquid flow stream back to the scrubber. Okay. So this is your stream 1. So this will go to your scrubber. It is given as 4.54 meter cube per hour. So this is water. Okay. The liquid being withdrawn for treatment and disposal is 0.54. This one. So you cannot always you cannot recirculate everything. Okay, you need to remove some of it for treatment in ETP or maybe STP, and then some of them you have to dispose of, like RO filter which you have at your home. So some of the water is disposed of it. So that is the same as this one. Now assume there is an inlet gas stream which is completely dry. Okay, it doesn't have any moisture in it. Okay, and the outlet stream, this one outlet gas stream, has 272.16 kg per hour of moisture in it. Okay, so how does this moisture gets added? So when you sprinkle water, because these temp gases are at higher temperature, so some of the heat is absorbed by the water and gets converted into moisture. Okay, so we need to find out how much makeup water is required. Okay, based on this all this data. So what we will do is how we will solve it. So we will first consider we have two unknowns here. Okay, so we don't know what's the makeup water which is given by X, and there is a Y meter cube per hour which is coming from the scrubber. Okay, we don't know how much it is coming from the scrubber. So we will consider two systems. Okay, one system will be this much, and other system would be this much. So I'll draw the first system. Okay, so let's say this is your scrubber. Okay? So this is your inlet gas stream. This is outlet gas stream. Mhm. This has zero moisture, right? 0 kg per hour, and this has 272.16 kg per hour, okay, of moisture going out. Now we have water coming in here, okay, and water going out from it. So this is 4.54 meter cube per hour, okay, and this is Y. So we know mass balance equation, right? So the let me see. Let me check again whether this is correct or not. This is fine. This is fine. This is fine. 4.55. Okay. So we will use mass balance equation, right? Simple mass balance. Summation of mass of in is equal to summation of mass of out. So the input is, this is one input, okay, and these are two out. So mass input is 4.54 meter cube per hour is equal to output is 272.16 plus y. So this is in kg per hour, right? And this is in meter cube per hour. So when you convert meter cube to kg for water, it is
2000.
multiplied by 1000. So you get y is equal to 4. Y is 4267.84 kg per hour. Okay. Or let's say 4.268 meter cube per hour. So this is in two digits, so you can just take it 4.27 meter cube per hour. Okay. Now this is one. This is the first system. Now the second system is recirculation tank, pump, disposed water, and this. Okay. So I'll draw this. So here is your system. Okay. Now here water is coming from the scrubber. Okay. Which is y stream, which is equal to 4.27 meter cube per hour. Then you are here. So we are adding some makeup water to it, right? Makeup water, which is given by x meter cube per hour. Now there is a pump here. Draw pump, which supplies to two parts. Okay, like this. One goes here, one goes here. So this stream is, I know, 4.54, right? And this stream is
0.45.
0.454.
454.
So now we need to find out x. Right? So again, similarly, mass balance, right? Summation of mass input is equal to summation of mass output. The input we have y and this x. Okay. So x plus y is equal to 4.54, right? Plus
Yes.
0.45.
0.455.
Because both of them are coming out of the recirculation tank. Okay. Now we know what y is, right? So 4.27. So similarly, we'll calculate x. 9.264.
No, no, no. 0.7.
Oh, sorry. I am mistakenly added it. 0.274.
724.
724.
24.
Okay.
Yes.
So one thing to notice it here is the actual value would be, uh, always remember it will be this plus this, because these two systems are going, these two water streams are going out from the system, from the whole
Okay.
system. So if you add both of them, you will get the answer. Okay, that
Okay.
is 2.2 plus 454. So you get 0.726, right? So whenever it comes for 1 mark, okay,
Mhm.
then just remember that It's just addition of the streams that is going out. Okay, unless there are multiple inputs. Okay, so here
Okay.
in this numerical we had only single input from outside, which is just this network water. Okay, and there are two
Yes.
outputs, stream 4 and stream 6. Okay, and rest
Good.
of them are just circulating inside the whole thing. Okay, so remember,
Okay.
when it comes to 1 mark, just add both of them if it's one and one. Okay, and if comes for 10 marks, then you have to solve this the way that I did. Okay, so
Okay.
you have to form two systems, find out y, find out x, and then the same way you will get the answer. Okay,
Okay.
and just for verification, you can just add this and this stream 4 and stream 6.